Okay, Year 12, I'm going to do a couple from the general solutions in exercise 5.2. And these can be a bit tricky, but we'll see how we go anyway. On your formula sheet, you get given the general solutions. And you need to remember that for every trig identity, there are an infinite amount of solutions. So if we just look at cos, and here's the cos graph, going on forever. And if we had, I don't know, let's say cos x equals half, we're going to get a solution here, we're going to get a solution here, we're going to get a solution here, we're going to get a solution here. Now, what you need to remember, that this solution here and this solution here are 2 pi apart. Oh, sorry, this solution here are 2 pi apart. And that this solution here, right, so, and this solution here are 2 pi apart. Because the curve repeats every 2 pi. And if you get two solutions between 0 and 2 pi, all right, here's 2 pi. Now let's get that out of the way. Here's 2 pi. There are my two solutions. They repeat again here. And they just moved along 2 pi. So the formula for cos theta equals A is theta equals 2n pi, however many iterations of 2 pi you want, plus or minus whatever the acute angle is, inverse cos of the acute angle, the ratio. Right, so let's have a look at the first one. Oh, isn't that lucky? 20a is cos A equals cos x equals a half. So therefore, x equals inverse cos of a half, and you can put that in your calculator, but by now you should be able to quickly go 1, 2, root 3, and here's the tricky bit, pi on 3. So your answer is, well, the acute angle is pi on 3. But we know the general solution is going to give us two answers in that 0 to 2 pi, and they're both going to repeat every 2 pi. So x is going to equal 2n pi plus or minus pi on 3. And that's the first answer. Now, sine is a little bit different because it's a different sign in each quadrant. So its formula is a little bit different. Let's just take C, which is 2 sine x equals root 3, which basically gives us sine x equals root 3 on 2. Now, from the formula sheet which you get given, it states if sine theta equals A, then the solution, the general solution, is theta equals pi n pi, whatever number of iterations of pi, plus, now to account for that negative sign changing in different spots, we get negative 1 to the n, and whatever the acute angle is, inverse sine of that. So here we go, back to our equation. So x equals inverse sine of root 3 on 2. And we can look above and see that that's going to be pi on 2. Pi on 3. It's the same angle. It's the same one. There it is. Opposite hypotenuse. So we get x equals pi on 3. and then we just put it in to this formula from our formula sheet to get the general solution. So x equals n pi plus -1 to the n, and there's a multiplication sign there, pi on 3. So they're pretty easy, thinking to yourself. Well, the issue comes when you have an equation. And if I go to E, I think Margaret gets right, but I think her equations are a bit dodgy. Now I'm going to do this two ways. There is a third way, but I'm not going to do it. And the equation is sin x plus cos x equals 1. Now, if there's a multitude, there's three different answers you can get for this. If you use the T formula, your solution will come out and you'll have to use a general formula for tan, because when you use the T formula, your final solution comes out tan theta equals something. So you get the tan general formula. If you use the r sine theta method, well, when your general formula comes out, it'll come out as a general sine formula. And if you use the r cos theta method, well, you'll get the cos theta general formula. Now, I'm going to do it with the r cos and the r sine, but I'm not going to do the T formula. If you want to go down that path, good luck to you. You'll still get the same answers if you follow the mathematical order, but I'm just going to do the r sine. Now, the first thing I want to do, I would look at this and go, well, I've got a plus there, I've got a sine and cos. I'm going to use the formula on my formula sheet that has a plus in the middle, and it's sine theta cos phi plus cos theta sine phi, and that equals sine theta plus phi. And that's on your formula sheet. So I want to get this looking like that. So the second thing I do is I go, all right, that's what I want to use, is I draw a little triangle. Now I realise that in front of each of these is a 1. So I go, well, they're the two short sides of my right angled triangle, and 1 squared plus 1 squared is 2 root 2. So it doesn't matter because I'm going to put my alpha there, and I'm going to go, well, sine alpha equals 1 on root 2, and cos alpha equals 1 on root 2. Alpha will equal pi on 4. We don't need that straight away. It doesn't matter which one we do. Now, I want it to look like sine theta cos phi. So I want over here, and I'm going to rewrite this equation, also write in black, sine x times 1 plus cos x times 1 equals 1. Now this is an equation. I don't want 1, I want to be able to write that 1 as a trig ratio. So I'm going to divide everything by root 2. And that's going to allow me, and I'm allowed to do that because it's an equation, that's going to allow me to write this whole section as a combination of trig ratios. So I'm going to get sine x. Now I want that to be cos alpha. So cos alpha plus cos x sine alpha equals 1 on root 2. Now that's written like that, I can write the whole equation as sine x plus alpha equals 1 on root 2. And now I'm just going to do it like the one I did in C. But, so I'm going to use the general formula that we did in B, but I'm going to have x plus alpha. So, x plus alpha equals inverse sine of 1 on root 2, which is pi on 4. Just so happens there's a lot of pi on 4s in this one. Well, what was the general formula again? Well, I look to my formula sheet, and sine theta equals A. The general form is theta equals n pi, plus minus 1 to the n inverse sine of A. So I just go down here, and it makes really easy sense. I just go, all right, well, x plus alpha, the general solution is n pi plus negative 1 n pi on 4. That's the inverse sine of what we got. But you need to remember that we've got this alpha to deal with, and alpha is equal to pi on 4, so x plus pi on 4 equals, I'm going to put this in brackets, n pi plus minus 1 to the n pi on 4, and then I'm just going to subtract that. So my general formula is x n pi plus minus 1 to the n pi on 4 minus that pi on 4. And there's my general formula. Now, I can get all the values that will give me the solutions to that, and if I start with n equals 0. So when n equals 0, I'll get x equals 0 pi plus minus 1 to the 0, which is just going to be 1, pi on 4, minus pi on 4, which equals 0 plus pi on 4, because minus 1 to the 0 is 1, minus pi on 4, which gives me 0. So my first answer to sine x plus cos x equaling 1 is 0, and that makes sense. You have a look at the curve. Well, when n equals 1, I get x equals 1 pi plus minus 1 to the 1 pi on 4 minus pi on 4, which gives me pi minus pi on 4 minus pi on 4, which gives me pi minus pi on 4, 2, which is pi on 2. Well, there's my first two solutions. What about when n equals 3? Well, I'll get x equals 3 pi plus, forgot n equals 2. N equals 2, I'll get 2 pi plus minus 1 to the 2 pi on 4 minus pi on 4, which gives me 2 pi plus pi on 4 minus pi on 4, which equals 2 pi. And would you look at that? It's 2 pi from the first one. Let's go on a bit further. And that was n equals 2. If I go n equals 3, I get x equals 3 pi plus minus 1 to the 3 pi on 4 minus pi on 4, which gives me 3 pi. That's going to become minus pi on 4 minus another pi on 4, which is 3 pi minus pi on 2. Well, that's 6 pi on 2, so that's going to be 5 pi on 2. Is that right? Yep. Now, look at this. Oh, 0, 2 pi. I wonder what the next one would be. It'd be 2 pi more. It would be 4 pi. and the next one 5 pi, 6 pi, and the next one 8 pi. Now this is pi. This one is pi on 2. Add another 4 pi on 2. That's 5 pi on 2. Because remember, 4 pi on 2 is 2 pi. Add another 4 pi on 2, and the next one would be 9 pi on 2. And another 4 pi on 2, 13 pi on 2. And it goes on. So this general formula sounds pretty good to me. Let's go and do this another way. Let's try this one. Instead of using sine, let's use cos. So I've got sine x plus cos x equals 1. Now, if I'm going to use a cos formula, remember, cos theta minus phi. Now, it's not on the formula sheet, so if you're going to use this one, so you have to be pretty smart, is cos theta cos phi plus sine theta sine phi. All you got to do is change the signs. All right, well, I need to have the coses first. Addition doesn't matter, so I'll just change it around and I'll write cos x plus sine x equals 1. Doesn't matter which way I do it. I know there's a 1 there and I know there's a 1 there. I draw my right angle triangle. 1 root 2 pi on, alpha, alpha. Therefore, cos alpha equals 1 on root 2 and sine alpha equals 1 on root 2. Therefore, alpha equals pi on 4. Alpha equals pi on 4. Right. Let's divide by root 2. Let's divide by root 2. Let's divide by root 2. And that'll give me cos x. Now, what do I want this to be? I want it to be cos alpha plus sine x sine alpha equals 1 on root 2. So that's cos x minus alpha equals 1 on root 2. I have to find the general solution to this. Righto. Well, x minus alpha equals inverse cos of 1 on root 2, which is lucky, it's pi on 4. Now the general solution, and as I look to my formula sheet again, it is x minus alpha equals 2n pi plus or minus inverse cos of a. Well, that was pi on 4, so it equals 2n pi plus or minus pi on 4. Well, I need to remember that alpha is pi on 4, so I'm going to get x minus alpha equals 2n pi plus or minus pi on 4. Sorry, and that's pi on 4. So x equals 2n pi plus or minus pi on 4 plus pi on 4. Now I could write two formulas from this, which is what I think Margaret's done. I'm just going to leave it like that. I'm happy about that being my general formula. Let's really make sure that we can see that that's a plus pi on 4. Righto. So what am I going to do? Let's test it. When n equals 0, what do I get? I get 2 times 0 pi plus or minus pi on 4. plus pi on 4. Well, if I take the minus pi on 4, I get minus pi on 4 plus pi on 4, well, that gives me 0. And if I go plus pi on 4 plus pi on 4, that gives me pi on 2. And that looks the same as what I got over here for the first two, 0 and pi on 2. So a different formula, same result. Let's try n equals, well, I get 2 times 1 pi plus or minus pi on 4 plus pi on 4. Let's take the negative first. So I get 2 pi minus pi on 4 plus pi on 4. Well, that's 2 pi. If I take the positive, I get 2 pi plus pi on 4 plus pi on 4, which is 2 pi plus pi on 2, which is 5 pi on 2. And we already know, because we've already done it, that they're the same answers. Look, you get the same answers, 0, pi on 2, 2 pi, pi on 2. So two different formulas, one coming from using sine, there it is, and one coming from using cos. And you could get a third one by using tan. Now, if you have a go at G, you're going to run into the same issue. I'm going to make a video of it and put it up. Only look at it after you've had a go at it.